Okay, on number 42, there's 3 parts to it. We're trying to find the open interval where the function is increasing or decreasing, and then we're going to apply the first derivative test to identify all relative extrema, and then we're going to graph it to validate our answers. So first, you're going to find the derivative of the function. So that'd be 1 plus 2 cosine x, and then you equal it to 0. So 2 cosine x equals -1, cosine x equals -1/2, and where cosine is -1/2 is when x equals 2 pi over 3 and 4 pi over 3. And so then those are going to be your critical points right here. So I made a number line, so 2 pi over 3 and 4 pi over 3. So we're going to now choose values from -infinity to 2 pi over 3, values from 2 pi over 3 to 4 pi over 3, and another value from 4 pi over 3 to infinity. So I chose 0, pi, and 5 pi over 3. When you put in 0, you get a positive number, so it's positive, it's increasing. When you put in pi, you get a negative number, so it's decreasing. And when I plug in 5 pi over 3, it's 2, so it's increasing. So it's increasing from -infinity to 2 pi over 3, decreasing from 2 pi over 3 to 4 pi over 3, and increasing again from 4 pi over 3 to infinity. So now we're going to mark it. So here's increasing, decreasing. So there's a max at 2 pi over 3. Here's decreasing, increasing. So here there's a min at 4 pi over 3. So we're going to plug these 2 points in. Here they are. These 2 points into the original function. And when you do that, you get 3.826, or to be more exact, you would get 2 pi over 3 plus square root of 3. And for 4 pi over 3, you would get 4 pi over 3 minus square root of 3, or 2.456. So your maximums would be, or your maximum would be 2 pi over 3, 3.826, and your minimum would be 4 pi over 3 and 2.456. And when you do graph this equation, you'll see that, let's see, at 2 pi over 3, it does equal 3.826, which is what we got. And then the minimum, 4 pi over 3, is 2.457, which I didn't round to, but we got that also. So yeah.